Hello, everybody. My name is Lucas Steam. I'm with Amtech Company. Today, we're going to go through Universal Laser Refresher. We're going to show you how to set up the machine for a job, design something to cut on the laser, and then go over maintenance, and then some project ideas, and answer any questions you guys have. So, yeah, we can start. First, laser setup. Like I said, we're going to make sure the cutting table is installed because we want to cut something. Most of the time, you'll keep the cutting table in anyway, so I never really take it out. We'll focus the laser to the bed, and then we will set up kind of our what material we're going to be cutting. We're going to do a couple of different ones, but I'm going to start off with a piece of acrylic, and we need to know the thickness of it. So if you want to go to the camera, that's over here. Okay, so our cutting table is already in, and we're using a desktop laser. This could be different depending on if you have a desktop or a platform, one that sits on the ground. For the desktop, the cutting table does kind of just fall in, but you'll take the engraving table out. For the desktop or for the platforms, the cutting table will actually sit on top of the engraver. Hopefully you know that already, but just in case. So I'm going to go ahead and turn on the laser just by hitting the power button. Okay, so what the laser did right there was it owned itself. It's important that you hear that noise. I don't know if you did hear it there, but basically the head is kind of moving into the corner just so the machine knows where it's at. So now we need to focus the laser to the bed. So the laser is in focus and will cut properly, basically. So to do that, we need to open the software called a Universal Control Panel. So I'm going to open that really quick on my computer. And the computer is connected to the laser, so Universal Control Panel should connect right to the laser. And this is where we'll kind of put our job when we're done designing and control the machine. But for now, I just want to focus the machine. So what I'm going to do is there's a couple buttons on the right side here. One of them is the focus view. Wherever I click with that button selected is where the laser's head will go and point at. So I'll kind of click just in the middle so it's easy for me to get to it. And then I'll go back to the laser and I will take this tool, which is the focus tool. This is calibrated for your laser, so it's important not to lose it. And what we're going to do is I'm going to lift this up. And you can see this is the head or the carriage here. This is where what I want to be focused to the table. And the way we're going to do that is we have this flat red part. Sometimes it's black on different machines. We want this flat part to be, or the bottom of it to be basically 2 inches from the bed. And that's why this is a 2.0 laser, or the lens is a 2.0. Different numbers will have a different tool because it needs a different focal length. So I'm going to set this little tool, the black part, just flat on the cutting table. And I want to lower or raise the bed using the buttons on the side, the 2 arrows that raises and lowers the bed, until the bottom of this red metal part hits this little chamfer here. I want it to get right into, as it hits the chamfer. If I were to go any higher, because it is chamfered, it would push the tool out. So I'm going to do that now and kind of show you this. So I'm just going up. And where I'm at right now is pretty good. The carriage is right at the bottom or the top of that chamfer. If I were to keep going up, you probably can't see it on the camera, but it did slightly push the tool out, which means I'm too high now. So if I lower it until that flat part is flush with the red part, and that's the flat part. So That's step one of focusing it. Now we need to tell the laser to remember this position. So we'll go back to the software without touching any of the buttons to move it up and down anymore. Okay, back in the software, I'm going to go to the System tab, which is the top middle one here. And I'm going to make sure Auto Z is enabled, this checkbox right here near my mouse cursor. Basically, what this does is it will tell the machine to move down the thickness that we tell the material, or what we say the material is. Because if we focus to the bed and then put a 1/2 inch of material in there, well, now it's not focused to the top of that material, it's still focused to the bed. This will make it move down 1/2 inch. So to remember this position where the cutting table is now, I'm going to hit calibrate under the cutting table. Hit calibrate. And this is the old position, our old Z0. We're going to hit save to overwrite it. And then yes. And now this position in the Z axis is zeroed out. If I were to hit calibrate again, it says 0 because we're still in that position. I can close out of this. You need to, like I said, measure the thickness of your material so we can tell the machine how thick it is so it can auto adjust. I would recommend calipers, but you can usually just buy material and it can be pretty close, but it's good to always check. Some material is different. Even if it says it's an 1/8 inch, it's good to just check. So I have a piece of acrylic here that I've already measured. It is an 1/8 inch. So with that in mind, we're going to design our job now. So I'm gonna design 2 jobs during this whole webinar. The first one is just going to be a little simple name tag to show you each of the processes that the laser can do. So there's 2 processes, and you can do them multiple different ways. And we need to use a 2D graphic design software to identify those processes so the laser knows what we want it to do. So we can either follow a vector path or do something called rastering, where it kind of moves back and forth, hitting the top of the material like an inkjet printer, but with a laser instead. When it follows the vector path, it pulses the laser, and that's usually for cutting or doing very fine engraving. And then the raster is for kind of like smacking the top of the material to be like big bold letters or a logo or something like that, or to do a whole image. In my PowerPoint, you see the kind of the parameters that each of these processes needs to be for the laser to know that that's what you want it to do. So for a vector cut, we need the line that we're making to be very thin in the software. In Corel Draw, which is what I'll be using today, that's called hairline. In something like Adobe Illustrator, it will be, you'll set the thickness to 0.01 points. And then for any software, that line needs to be RGB red, meaning 255 red, 0 blue, and green. That's how computers see color, and you can change that. And I'll show you all of this when we get to Corel Draw. Vector engrave is almost exactly the same, but instead of RGB red, it'll be RGB blue. And then anything else in your design that isn't exactly those 2 things, the laser software will convert it to grayscale and do the raster type job. So usually for rastering, if you want kind of the deepest color, you'll want it to just be black. So let's go over to Corel Draw, and I can kind of show you how to design something simply. And we'll do a little name tag just to show each thing. So in Corel Draw, it's usually a good idea to make your template the size of your laser, like bed. So ours is 24 by 12, so I've already set that. And my primary color mode is RGB because I want to use RGB colors. We're using a slightly older version of Corel Draw, so it might look a little different, but most software should ask this when you make a new job. So I'll hit OK. And I'm going to just start drawing some boxes to make a little name tag. So our little outer box, and I can change the size of it. We'll just make it 2 inches, something like that. So this will be our outer box, like I said, the actual name tag. So I want this to be the RGB red, which I can go over here to the right. This is already set to 255R and then 0 for B and G. I can right click that to change the outlines of that. For cut lines and engraving lines, you pretty much want to do no fill. You don't want the laser to kind of see like a weird gray inside. So no fill would just be like the X over here. It's already set to that, but just so you know. So I have the red. Now I need to make it as thin as the software kind of lets me. And in CorelDRAW, it's up here, and I do Paradigm. So that's set. That'll cut in our machine. So now I can make another box. And this one I'll do an engrave, which is the same as the cut, but instead of red, we'll do blue. So we'll go over here, pick blue, and we'll also make this hairline. That's two of the processes. The last is the raster, and we can just do, you can do anything really, but I'm just going to do text. Text looks really good with the raster, and I'll just put my name, and I'll send that over. And it already came in black. Doesn't matter the thickness or the color as long as it's something different from the other two. And like I said, black is usually good. The darker the color, the closer the dots are together when you raster. So black is usually the best that shows up. So I have my design. Now I need to send it to the other software. So I'm going to go to File, Print, and then I need to choose my laser's printer drivers. And this computer has multiple printer drivers or laser drivers saved on it because we use it for a lot of different lasers. Hopefully yours will just have your model. So our model, the one I'm using right now, is 350/60 DT. So we selected that. Before we hit apply and OK, we're going to go and hit preferences. This can change depending on the software you're using. Sometimes it's a call wheel to open what's called the material database. This is part of the laser software. This is where we'll pick what material we're cutting, tell it how thick it is, and then we'll eventually send it to the other part of the software. So I'm going to do this on acrylic. So plastic, acrylic, and then continuous cast acrylic is usually the regular type of acrylic you'll buy. Material thickness is already actually set to 1/8 of an inch, so I don't have to change it, but you would type that down there in this bottom section. So I can hit apply, OK. And now that those settings are done, I can hit OK again or print depending on the software you're using. And that's what sends it to the other software. So to open the rest of the software, I click the little, usually it hides in the taskbar down here. So I click the arrow, and it's this red symbol here, Universal Laser System Control Panel. Okay, so you can see there's my job. It already sent it in. Whenever you open the software, it always opens the last job that was cut on it. If you see what like the colors you expect, then you did it right. Like I said before, anything that isn't exactly the engrave or the cut will turn it into grayscale at this part. So you know you did something wrong. It's if your like outside line was like gray or black. It needs you can tell you did right if it comes in as the colors you expected. Okay, so we have our job in here. We can use this tool over here on the right called the relocate tool. It's this middle one with the arrows, and I can click and drag it around. And wherever my job lands on this area is where it'll land, or where the laser will try to process it on the bed. And you can see the kind of the rulers represent the bed itself. So I'm gonna kind of place it at the top left for now, and I'm gonna put in my piece, and we're gonna line it up. Move this out. Okay. So I'm just going to do it at the top left here. Just for, actually, I can see it better somewhere else. Maybe right in the middle. See it a little better. So I want my job to land somewhere on here, obviously. So if I go back to the software, I can use the focus tool again, that one that moves the actual laser itself, and kind of click in the middle. And what's nice about the laser is when the door is open, there's a little red dot laser, like a light, that will point at where the laser is going to land to. So you probably can't see it from this camera, but the point is right there. So I could keep moving around the laser with the software to try to line this up. But because it's such a small piece, I could just also move the piece itself. So now my dot is kind of up in this corner. I'm saving material, but I'm not playing right in the middle. So I have my dot here. Now I want to move my job towards that dot. So I can hit the relocate view again to move my part. And instead of clicking and dragging it to try to line it up, I can click some of these anchor points. So I have the top left one selected. And I can hit to pointer, and it moves that anchor point to where my pointer is at that moment. So that's makes it really easy to line stuff up. That's like kind of the go-to. Another button that's kind of useful after the relocate view is the duplicate view. This lets you just duplicate your job on the X and Y axis. So I can up the quantity and then displace it, which is just the distance between each one, and then hit apply. And now I've duplicated it. I'm not going to actually do that for now, but just so you know it's there, it makes it a lot easier. Go back to 1. Okay, so we've already focused. We told the laser how thick the material is, so it knows in Z where it's at. And then what we just did kind of tells it where it is in the X and Y axis. So we're pretty much ready to go. So when you are ready, obviously you close the door. You want to turn on your extraction, which ours is down here, and it's going to get loud. And then I can either hit the start button on the laser or the green button on the software. I'll just hit the start button on the laser. And we're good. And I don't know if you can hear me. We'll just let that go. It should only take about a minute. And then we'll pull it out. Okay, so it's finished. I turned off the Beaufort. I'm going to open the door. And I cut it pretty well. And obviously this is super simple, but you can see the cut, obviously, the small engraved line, and then the raster, which is my name. So that kind of shows each of the 3 processes very simply. But we can do kind of more with those processes. But first, we'll go through the maintenance of the machine. I'll go back to my PowerPoint. So the most important thing with maintenance is keeping the optics clean. The optics are what bounce around the laser and bring it to a focal point. If any debris gets on that while the laser passes or hits those optics, it will heat up the glass, and from heating it up, it's possible that it can shatter. So I'm going to show you real quickly just how to clean it. I'm going to turn the laser off for now, just so it's not as loud. So for the desktop machines, the laser enters from the back here through the beam window. The beam window usually doesn't get super dirty, but sometimes it's good to clean it, and I can show you how to do that as well. After it goes through the beam window, it hits mirror 2, which is way over here, this little red handle. And this is just magnetic in there, so you can just pull it out. And then after mirror 2, it bounces into the carriage. And this is just held in by some thumb screws. It hits the what's called mirror 3, and then goes into the optic, which brings it to the focal point. So to clean these, your machine should come with optical cleaner. If you run out of this, it is just basic optical cleaner. There's nothing special about it. It's the same type of cleaner they use to clean like camera lenses. So what I do is you want to get like lid-free cotton swabs, and your machine should have came with like a pack of them, but obviously you'll run out eventually. And you'll use the cotton swabs to clean the beam window in the back and then the mirrors. But for the optic, you'll use optic lens tissue, which is this stuff. And it kind of feels like almost like a dryer sheet, and you'll rip it off, but I'll show you that as well. So to clean the mirror, is that lined up okay? Can you see that? I usually just drop one drop onto it. And these mirrors aren't very dirty, but just to show you. And then I usually kind of roll it along. And it's usually a good idea to not rub like a used part of the cotton swab onto the mirror or the optic if you're cleaning the optic again, because that obviously might have like dirt on it and you don't want to rub it back on. But yeah, that's basically it. I'll put this back. Obviously, for these, make sure it's pointed the right way. If you don't have it pointed the right way, your laser will just hit the back of this, and that's not good. So the process is the same for obviously mirror 3. You just put a drop on, use a cotton swab. For the optic has two sides, so we'll have to clean both. The bottom will usually be much more dirty because that's what's actually kind of pointing towards the debris that's getting knocked up. But anyway, what I'm going to do is I'm going to rip off a sheet of this. And then I will put a drop, and I'm only going to clean one side just to show you, but I'll put a drop on the optic, the lens, I guess. And I usually only use one drop. You never really need more than that. I like to fold this up so I can kind of have more control with it. And it's kind of the same as the cotton swab idea where I'll just rub and then fold that part away so I don't re-rub it on. And I just do that until it's clean. And then we'll put it back in. So this is obviously a desktop machine. They have platform machines too. For the platform, it's almost exactly the same, but the second mirror, you actually can't really pull out of the machine. It's not magnetized. There's a black cover here that has a thumb screw. You'll undo the thumb screw, pull off the black cover, and the mirror will just be sitting there. Because you can't pull the mirror out, I usually saturate the cotton swab itself and then just do what I did anyway. So that's clean. You can clean the beam window too, and we'll do exactly that, where I will just put a drop on the swab, or a couple drops just to get it nice and saturated, and then I'll just roll it along the window. And this is pretty far away from the camera, so you probably can't see it, but it's all right. That's the main maintenance. Obviously, it's a good idea just to keep the machine tidy. You can always run like a shop vac through it or wipe it down with wipes. But the optics are very important because if you don't clean those will break. One important note, you only want to clean the optics when they need to be cleaned. So it's a good idea to check them maybe once a day if you're using the laser a lot. But if you don't see that it needs to be cleaned, and you'll know it needs to be cleaned if it'll look like almost like a fingerprint smudge, you should not clean it just because it's at risk of breaking it. This solution can take off the coating that's on the optics, which is kind of what's protecting it from the laser. But just clean it when you need to clean. Okay, so that's maintenance. Yeah. So project ideas, what we did was really, really simple. Other things, and I'm going to walk up to the big camera just to show these. So this is really simple. It's actually held together by tape because we didn't glue it. And I can cut this right now if we want. But this is a little box that has these little pieces sticking out that kind of fit together. And this is really easy to make and design, especially if you're using like a CAD software. And this is kind of an extreme version of it. This is like a wine holding box. And this even slides up. And then if you have other machines, like a 3D printer, especially one that's highly accurate, we sell the Stratasys, our F170, which is over there off camera. You can kind of, what we did is we measured how big these USB sticks are and then made almost like a jig for them. And then we always can put this jig at the top left. We made the job and then we just load it up and just hit run. It's a lot quicker than trying to line everything up. And then it's really hard to see on camera, but these are engraved with like our logo. If you do want to make something like this box, you can design it. And the way you would design it is you need to know the thickness of your material and then almost make cutaways for it. So like this cutaway where this other one fits is the size of the thickness of the materials. That's kind of hard to do in a 2D software, but it's really easy to do in a CAD software. And there's a website, there's a couple websites online that kind of do it for you. And if you show me my screen, I can kind of show you one of the websites. It's really easy. So this is one of the websites. You just tell it how big you want it. So 4 by 4 by 4. And this can be either the inside or the outside dimensions. You tell it how thick the material is, open or closed box, and then how the edges of the box are. So flat would just be flat. You would kind of glue it together, and you would glue these together too. But obviously this adds more surface area, more strength. But finger is what I did for this little box. And then you can up the size of the finger or the quantity of them. And then you hit download box plans. And then you save it as an SVG, and you can put that into CorelDRAW and then print it just like you would like a design that you made. So if I open CorelDRAW, make a new job, and then we'll just open our downloads and click and drag it into it. If it opens. So these lines didn't come in exactly correct. They're the right color, but they're not that hairline thickness. So what we can do is we can just click it and do hairline, and it should change it all. So there you go. So I go to File, and it's the same process, File, Print, choose our laser. Preferences, instead of doing acrylic, we can do something else. Another popular material is MDF. That's what this little box is made of. And then obviously any types of wood is good too. So MDF is under natural, wood, and then medium density fiberboard. We have some sitting around somewhere. MDF. I'll put that in the machine. I already know this MDF is about 1/8 of an inch. I've already measured it, so I don't really need to change that. So I'll just hit apply, OK. OK, and that sends it to our software. There it is, and then we can cut it. Because I already focused it, the laser, it stays in focus for a pretty long time, so I don't need to do that again. If you feel like the laser isn't cutting properly or isn't hitting the top of the material right, that's when you would maybe go and try to focus it again. Maybe it's possible that it can fall out of that focus. But anyway, we can move this. And our material kind of takes up the entire build area, so we're probably good. We don't even need to really line it up. So I can cut this as well. Turn the laser back on. So I'm going to cut this. While I'm cutting this, go ahead and if you guys have any questions, type it in the chat, and then Jake, the guy behind the camera, will tell me the questions and I will answer.
No questions so far.
Sweet.
Lori asked, how do you load other material types into the laser software?
That's a good question. I'll show you. Okay. So right now I'm in the just regular software. I can go down to settings down here. And this will pull up the material database again. And to create a new material to add to this list, you have to go off of a material already in here. So I could do, MDF again. I can go into manual control and kind of change what these colors mean. So this one, so this exact material. So once I do change it, then I lower the speed of this. Once I do that, I can then hit save. That'll ask me to save it as the same file type that all of these materials are. So if I put it on the desktop, yes, there's something. Maybe I can't save it to the desktop. I think it needs to be in a specific place or computer, which is probably where it wanted me to save it a second ago. No, this is down. Hold on. Well, let me save this.
Normally does make sense.
Normally it does let you save it, I promise. That's very strange.
We can look into that and get back to you as well.
Yeah. I don't know why it won't. Normally you'd save it, and then it would become a part of this list as whatever you name it. And then you would obviously, test it, make sure that that actually works with the new material you have in there. Something I would like to note though, there is a ton of material. I've never found one that wasn't here. But I'm sure there is some basics for you. Like I said, try it on your computer, see if it lets you save it, because I don't know why I haven't done this.
PDL asks, how can we access the recording of this meeting?
Right, it should be emailed to you, but we're gonna post it on YouTube, our YouTube channel anyway. So we have a YouTube channel, this Airtech company. But we have a bunch of other videos like this, where we show how to use certain parts of the laser. Yeah, I can show it, but I didn't.
He's pulling it up to show you guys, but we actually have a lot of past webinars that we've done saved on our Amtech company YouTube channel as well. So if there's a topic that you ever miss, just keep an eye out there and you should see the recording of it.
Yeah, so right at the top, there's a bunch of laser videos. We have videos on our other machines, like our 3D printers, vinyl cutters. But this video will be posted on this video. It's a long job. I should have made it smaller, but
So yeah,
big box.
are there any other questions?
We'll stick around. Feel free to go if you need to go, but that's basically the crash course. If you have any questions later than you think of, you can email me. It's lucas@amtechcompany.com. You can also email support@amtechcompany.com to send a kind of a general support message in case I'm not available.
You're gonna send out the PowerPoint, right?
Yeah, we can send out the PowerPoint too. We'll stick around to this part's done, and if anybody's still around, we can show you the part. But feel free to go if you need to go. And thank you for joining.
Gary's been.
Gary, we're not. What Gary? Our Gary? Our Gary.
Here's the thing.
No problem. Let's go. No other questions.
No other questions. Lori and Ryan are our last people in here.
Thanks for sticking around. Maybe they want to see the part. See if it actually works.
Yeah. I think there's actually a setting in that website that we use for the box as well to adjust the curve settings. So you can get like a tighter or looser fit, which is pretty nice.
Yeah, so once this comes out, you'll be able to see it. They should slide in pretty well. And there's other websites that do that same thing that are even more advanced that make different types of boxes. I've seen the same type of process be used to make like 3D sculptures, buildings, architecture. It's very cool. You can kind of do a lot of stuff with this type of like cutting away to make wood or MDF fit together.
Lori, if you are lasering into an object that is more than 2 inches thick, do you focus to the top of the material?
So, 2 inches thick. Oh yeah, 2 inches thick. You'll probably never be able to cut through. Just because of that problem, it's so thick that the focal view of the laser won't ever be in focus. So you would just focus on the top, and I would only engrave the top of that material. You would never be able to cut through it anyway. So what if you were focusing to the top of the material, you actually don't have to use that auto Z function, and you don't have to calibrate it either. You can turn that function off in the system and just use the focus tool directly to the top of the material and just hit go at that point.
With the rule of thumb on thickness of material compared to wattage of the laser.
Right. So it's about a tenth of an inch per 10 watts of your laser. So we have I think a 50 watt in here, which means we can probably do up to half-inch material. And that can obviously change depending on how soft the material is. But yeah, I don't think a Universal will ever be able to go through 2 inches. And that's not even a power issue. That's more of because it won't be in focus. Yeah. What?
Which part of the document?
It's 7th. It's on the last one. Yeah. It's on our alarm. Yeah. Okay. If anybody's still here.
Yep. Lori's still here.
Laura's still here. She's here to see the box. Is it on this camera?
Yep.
Cool. I can put it together right here. So something nice about that software is it kind of labels everything for you, which is convenient. That maybe. And obviously you would glue this and not just do it the way I'm doing it. But we can try to see if it fits together well. It does feel like it's fitting together pretty well. Let's do this first.
Probably hard on that honeycomb as
It's
well.
not easy.
Not quite flat. Oh,
There we go.
you know, that almost gives the illusion of a completed box with just the three sides.
Oh, yeah, it doesn't. There you go. Again, you would glue this in steps. You would not do what I'm doing right now. I'm trying to hold it all together. Wow, beautiful.
Perfect.
The bottom, perfect. There you go.
All right.
Cool. That's it.
Thanks for sticking around.
Thanks for sticking around. Yeah, it's been great. Let me know if you have any questions. Feel free to email me.
All right. Bye bye.
So long.